This is factorising in simple cases, where factorising is the process of removing common factors from terms and putting them outside brackets. And the key to getting it right is to recognise the type of factorisation right from the start. So here we have three different types of factorisation: common number factor, common unknown factor, and a quadratic. Well, we won't be dealing with quadratics in this video. It's a quadratic whenever you have an x squared and a purely number term. So that's a quadratic, x squared and the minus 14. This is a quadratic because it's got an x squared and a minus 36. This isn't a quadratic. The x squared on its own is not enough to make something a quadratic. This isn't, it hasn't even got an x squared. This is, the fact that the x squared is at the end doesn't make any difference. It's still a quadratic. So in this video we're going to look at the cases which are not quadratics. They must be factorised by a different technique. So in the simple cases we take out all the common unknowns in all the terms. So in this case we take out the common x. Then we find the highest common numerical factor shared, and for 3 and 6 it's 3. We divide that out and we have our answer. The result is something that is equal to what we started with. 4 brackets x plus 5, and we expand out is 4x plus 20. So 4x plus 20 factorises to 4x plus 5. If it doesn't equal when we expand it out again, then we haven't factorised correctly. It's the exact opposite of expanding. Any negatives stay where they are. In this case, minus 21, so the negative sign stays when we divide out the 3. Negative 5x, so the negative stays with the x. We can write it that way around if we want, but there's no need to. We can factorise out common negatives. Both the terms here are negative, so we can take out minus 2, but we have to be very careful when we do that, because all the remaining terms in the brackets are now positive, so that it expands out correctly. Often you have to remove multiple variables as factors. In this case, the x cubed and x squared share an x squared term, so we must remove both of them. In this case, an x and a y is in common, so we remove both of them. Sometimes the number doesn't even divide out exactly. The highest common factor of 6 and 9 is 3. So dividing out the 3 leaves 2, and dividing out the 3 from the 9 leaves 3. There's nothing that goes into 40 or 30 exactly. 10 goes into both of them, so we divide it out. If the highest common factor is exactly one of the terms, then a 1 is left afterwards. So 6 and 3 have a highest common factor of 3. So when I divide it out, there's plus 1, so that the 3 times the 1 gives me back my 3 on expansion. And that's true also with unknowns. Common x, take the x out, I have to leave plus 1, so that x times plus 1 gives me my plus 1x back on expansion. You can do it for more than 2 terms. Here, all 3 of these numbers divide evenly by 3, so we can factorise out 3. Here, each of the terms shares a common x, so we can factorise out that common x. Sometimes you actually need to do this before we do a quadratic factorisation. So in a case like this, we have to do a simple factorisation first. Take the 20 out of each of the terms, so they're left with a simple quadratic, which we can factorise separately. So, the process is identify that you don't have a quadratic that doesn't have an x squared and a number term. You take out any common unknowns. Now notice this has got an x squared, it's not a quadratic because there's no number term. The x's are in common, they are removed. Then you divide out the highest common numerical factors. this case it's a 3, and whatever's left behind gives what must be the exact opposite of expanding.